Hey, good afternoon, everybody. Thanks for joining this NASEO webinar on building batteries. We will let everybody get logged in and get started in a couple minutes here. Good afternoon, everybody. We're a couple minutes after the hour, so let's go ahead and get started. We got a busy agenda. Thanks, everybody, for joining. My name is Dylan Tucker. I'm a senior program manager with the National Association of State Energy Officials. Thanks, everybody, for joining this webinar, Building Batteries, Enhancing Supply Chains and Domestic Manufacturing for Critical Materials and Batteries. It's co-hosted by NASEO's Transportation and Electricity Committees. One of the primary roles of NASEO's members, the state energy offices, is energy planning. And states all around the country are looking to energy storage and batteries as a solution for grid resiliency, for transportation and electrification, and also to support higher renewable penetration on the grid. So as states plans, and there's federal goals from the Biden administration to get literally millions of batteries deployed around the country over the next decade or so. So we want to take a deeper look through this webinar on the supply chains and manufacturing capabilities, and also the kind of the economic opportunities that come along with these investments. So we've got a great panel of experts online to talk about these issues. It's going to be led by our moderator, Star Hodge, who's the State Energy Program Manager for the North Carolina Department of Environmental Quality. And Star is going to introduce some great panelists we have lined up. So I'll pass things to her in a moment. But before that, I just wanted to go over some logistics. Everybody's on mute, but we're encouraging questions throughout. We're going to have 2 opportunities for Q&A after the first two speakers, and as well as after the industry speakers at the end. So if you do have questions, feel free to type them in the Q&A feature, and we can read them out for you, or just use the raise hand feature during the Q&A portion, and we can unmute you and you can ask the question directly. So thanks again for joining, and without further delay, I'll pass things over to Star.
Thank you so much, Dylan. Thank you all for joining us this afternoon. As Dylan said, I'm Star Hodge. I'm the State Energy Program Manager for the North Carolina Department of Environmental Quality. And this is such a very important topic to us, and I'm so glad that I could participate today. In the state of North Carolina, we are committed to addressing climate change and to transitioning our state to a clean energy economy. And we think that battery storage can be a very important part of this. We have several recent policy documents that are helping us to get to our clean energy future, and they include our North Carolina Clean Energy Plan, which was delivered to the governor in October of 2019. Also, we have our North Carolina Climate Risk Assessment and Resiliency Plan, which was produced last year in 2020. And there are several recommendations in those policy documents that are just helping us to get to the cleaner energy future in North Carolina. As of the first quarter of this year, 2021, North Carolina was third in the nation for installed solar capacity with over 7,000 megawatts of solar. And we believe and know that battery storage that can play an important part in helping us to integrate more renewable energy into our grid. Also very important to us is electric vehicles. With the Executive Order 80, which was issued by our Governor Cooper in 2018, we have a goal of 80,000 zero emission vehicles in our state to be registered by 2025. And we believe that batteries can play a huge part in electric transportation. Also in North Carolina, energy efficiency and clean energy workforce development is very important with us. We're working with other state agencies. We're working with community colleges and universities, and we're working very hard with our energy industry to make sure that we can continue with workforce development in our state. And you're going to hear from some Piedmont Lithium and Live Cycle also later in the session today. So we hope that you all will enjoy these topics, and we'll start out with our very first speakers who will give us sort of a broad overview. And first we'd like to introduce Melanie Kinderdine. She is the Principal and Executive Vice President for Energy Futures Initiatives. And immediately following Melody, we will have Dr. Helena Kazduzian, and she is the Technology Manager for U.S. Department of Energy. So I'd like to turn it over to Melanie at this time.
Great, thank you so much. And I am going to share my screen. Let's see, is everyone seeing that?
Yeah, it's just not in full screen yet.
Yeah. And I can't start my video. It's not, so this is just a disembodied voice, okay? Unless you all wanted to show me and allow my video to be on. You're controlling it. Okay. Great, thank you. And thank you so much, Dylan and Star and Kelsey. I know Kelsey and Dylan have done a lot of work to put this together. We really appreciate it. I think it's a hugely important topic. The Energy Futures Initiative, we are a small think tank founded Joe Heiser, me, and former Secretary of Energy Moniz, and are looking at the range of options, technology and policy options for deep decarbonization. And clearly, this batteries figure heavily into that picture. And this is global. This is based on IEA data, and what you see here, the light gold and is autos and batteries. The dark gold is grid scale. Red is decentralized, and this is the we're looking at beyond 2 degrees, which is where everyone is, what the thinking is now. And what you see here, okay, the vast bulk of the battery use or energy storage use, so that'll be batteries, is by electric vehicles. And from 2020 to 2050, and beyond 2 degrees, which is net zero, energy storage for EVs goes from approximately 0.5 gigawatt hours in 2020 to 41 gigawatt hours in 2050, an 800% increase. This is another, again, this is global, and I think global numbers are important because there's competition for the materials that you will need for EVs, batteries, et cetera, et cetera. So that's millions of vehicles in 2019, numbers in 2030. And the world will go from 5 million EVs to 140, so 135 million increase. Those are light duty plug-ins. Okay, the first was light duties. That goes from 1 million to 60 million. Here you've got commercial battery EVs going from 0 to 30 million, and then buses from 0 to 5 million by 2030. So that's 5, 35, 65, 100, 120, 185 million vehicles in the next 9 years that will be using, at this point in time, batteries. And you see the estimate there for the drop in battery cost. That's VNF, and that's gone from $1,100 per kilowatt hour to $137. But as everyone knows, you use lithium and cobalt. These are lithium prices. The difference between 2002 and 2018, from $2,000 a metric ton to $18,000 a metric ton in 2018. And so it's clearly a reflection of demand for lithium. And here in a 100% EV world, demand for lithium and cobalt would increase by roughly 3,000% and 2,000%. So again, supply chain issues, things we need to be very cognizant of. And what you're seeing here, we did a study of in California in 2019, and it was a study, it was a technology study, not a policy study. It was assumed the policies in California and what technologies did they need to meet those goals. And what you're seeing there, the blue is wind, the red is solar. This is wind and solar generation for every day in 2017, I believe. Yeah, 2017. And so what you see there at the end in California, 90 days with little to no wind. We were concerned that this was an aberration, so we looked at Texas, one of the wind capitals of the country, also 90 days with no wind. You have 10, 11 days, a week in a row with no wind. And I would say the difference between California and Texas, it was just different times of the year when you saw no wind. And I should also say these are data. This is not modeling, these are data. So those are actual numbers. And so you had these 10, you had 1/4 of the year basically with no wind, little to no wind, and 11 days in a row with no wind. This is installed battery storage in California in 2019, 617 megawatt hours. And those brown bars you see there, that is duration. So you have some 6-hour duration. I don't know what that is, okay? But it's basically 4 hours duration and 617 megawatt hours. California's total generation that same year, 202,000 megawatt hours. So, and to meet those 10, 11 days in a row with no wind, it's linear. As I understand it, it's 4 hours plus 4 hours plus 4 hours plus 4 hours. So you're talking about a lot of batteries here. This is pretty hot off the presses. This is from EIA. Total system levelized cost of electricity and storage are in red. Capital cost and capacity factors light blue, dark blue. That's combustion turbines, gas combustion turbines. Those are your NGCCs. Capital cost $778, and total cost per megawatt hour, I can't see the top of it, $37, okay, with a capacity factor of 87%. Nuclear, $69, 90% capacity factor. Look at the difference in the capital cost. Battery storage, $122, capital cost $58, 10% capacity factors. There you're looking at geothermal. So you can see the numbers there as well. That's dispatchable. Okay, here's something surprising. This is your onshore wind cost. So $36 or $37. When you hear the 37 number, it does not include the cost of battery storage. So adding to that, you got $165, okay, a megawatt hour. We need to be cognizant of that. Particularly for cost lower income communities. And those are the costs. One other thing I would add about this, hydro, for the first time ever, hydro, which is zero emitting, as everyone knows, has been moved by EIA to non-dispatchable. I was shocked to see this. I read their rationale because it's always been dispatchable. It's because of drought, melting glaciers, et cetera, et cetera. Hydro is no longer considered immediately dispatchable. So here's lithium, cobalt, and nickel production reserves for, and that's what you need for lithium-ion batteries. You can vary the amount of cobalt and nickel. And this is a World Bank study. What you see here, US 35,000, this is all metric tons, 35,000 metric tons of lithium. Chile, 8 million metric tons, Australia, 2.7 million. And from what I understand, I went to Katowice, Poland for COP24. China is basically buying up the lithium mines in Australia. Cobalt, US 38,000 metric tons, Congo, 3.4 million metric tons, and then Australia, again, 1.2 million metric tons. Nickel, as I said, you can vary the amounts. US 110,000 metric tons, and I gotta move my face. Indonesia, 21 million, Brazil, 11 million. So the meeting the clean energy ministerial's target of 30 million EVs by 2030 would require 3 times as much cobalt as we currently use, as we used in 2017. Reserves would last 23 years. And that just explains the difference between nickel and cobalt variation. I think this is the last slide, maybe one more. Global production shares. This is the EU, the US, and China. And first, and it's nickel, cobalt, lithium, manganese, et cetera, et cetera. You can see there, US does very little, EU a little bit more. That's in the mining. In the processing, US very little. Look at China in chemical processing. Cathode, anode production, same. We're doing nothing here. They aren't in the EU either. China's doing a vast majority of it. Same thing in lithium-ion battery cell manufacturing. We need to build up those supply chains in the US. And so that's just a little framing to give you some perspective on what IEA says will be the demand for EVs and grid scale batteries. Who's making them? It's China, and where the resources are for them, and the limitations, the 4-hour limitation that you see in current battery storage. So thank you so much.
Thank you, Melanie. If you have questions, please put those in the chat, and we'll pass things on now to Dr. Helena, and after her, we will have we'll allow questions for both of the first 2 speakers. We're ready for
you. You see my screen?
Yes. Mm-hmm.
Okay, great. Well, thanks so much, Dar, and everyone for organizing this today. I'm Helena Kazuzian. I'm a technology manager in BOE's Advanced Manufacturing Office. Talk a little bit about critical materials for energy storage today with a focus on lithium-ion batteries. I'm not going to harp too much on the supply chain because I think Melanie already covered a lot of those points. But just to underline that we are moving from a fuel-intensive energy economy to a mineral-intensive energy economy. So the International Energy Agency, released a report this year about the role of critical minerals in clean energy technologies, and we see that it could take up to 4 times more minerals to meet the demand as we're trying to meet our agreements, our commitments to the Paris Climate Agreement, for example. This is a more specific example, but electric cars, use a lot more minerals than conventional cars that use internal combustion engines. And so when we think about critical minerals or materials, we're really focused on those materials that are both subject to supply chain risk or disruption, and also are important to a particular stakeholder. In the Department of Energy, we think about the importance of energy technologies. And so we think about supply risk, at different parts of the supply chain, right? When we look at extraction, for example, Australia is, the #1 miner of lithium in the world, but they don't have the processing facilities. So, it is dominated by China. And so as we're building up capacity, we have to think about the fact that even if we do material recovery or mining, if we don't have the processing and refining capabilities, we end up re-importing our own materials in the form of value-added components and manufactured products. So it's not the only type of supply risk, but it is one I wanted to underline today. Most of the production of materials for other countries are really concentrated.
Excuse me, Helena. Excuse me. Is your screen in presenter mode? The information is very small. Thank you. That's better.
Okay, sorry about that. Okay. Yeah, so let's pause there for a second. But yeah, you can see, again, just 1 or 2 countries, sometimes 3, producing a particular critical material. And with lithium, nickel, and cobalt being really important for lithium-ion battery cathode production. And so I'll just kind of, there's a lot going on in the federal government, which I think is a good thing. So this is not comprehensive, but definitely I think the highlights that I wanted to talk about today. So earlier this year in February, President Biden issued executive order on American supply chains, and that resulted in 400-day reports on different supply chain sectors. And the 3 I highlight here are large capacity batteries, critical and strategic materials, and semiconductors, all of which are used in electric vehicles. We also, DOE is also currently drafting a 1-year report on the energy industrial base to better understand the risk there. So, from the 100-day reports, we get a really, we get a good sense of what the risks are. We have recommendations on what to do to address those risks, and we're diving a little bit more specifically for particular supply chains in the energy industrial base report. I'll give an example. Everything's linked and you'll have access to these slides, but to address the risks associated with large capacity batteries and think about domestic production, we're working on implementing sustainability standards for federal procurement. So as we try to stimulate some demand in the market and send some signals by, converting federal fleets to electric vehicles, for instance, we're doing that in a way that is sustainable, transparent, and hopefully sets example for others. We're also, so this is informing some of DOE's activities that are longstanding. We've been working in critical materials for over a decade in the applied space and much longer in the fundamental research space. But DOE has the Energy Storage Grand Challenge. This is more broad than lithium-ion batteries, thinking about grid storage as well. So there's other technologies, right, for grid storage. And we recently announced the long duration Earthshot, right? So we know, as Melanie mentioned, wind is not dispatchable. We need long-term duration storage, to make that, to fully utilize those resources, right? The Federal Consortium on Advanced Batteries is led by DOE, but is really the interagency entity. They wrote the report on large capacity batteries for the most part, and also developed this national blueprint on lithium batteries, which I'll talk about a little bit. And then this is also informed by DOE's critical material strategy, and we'll talk about that in a second as well. So just, a little bit more detail on some of these things I just mentioned. These are the high level goals, recommendations from the executive order report up front by the White House. So you can see there's a lot of threads through these, right? Workforce development shows up in all 3 of these initiatives, thinking about stimulating domestic production and capabilities that are underpinned by research, development, and demonstration activities, in DOE and other agencies. And you can see, particularly for the batteries, right, we're thinking about access to our own material sources, both from traditional sources, mine tailings, end-of-life components, and also thinking about, growing our manufacturing capabilities, as well as building our workforce to make sure we have folks that can fill those capabilities. just flying around along here so we have time for questions. So this is all underpinned by DOE's critical material strategy, which is based on 3 pillars: to diversify the supply, so we don't have a single point of failure, whether that's domestic or foreign. Developing substitutes, so we can actually reduce our reliance on some of these materials and free them up for really strategic applications, especially for the defense sector. Looking at just basically better stewardship of our materials. So can we actually be more efficient along the entire supply chain? Can we reuse components? Can we recycle materials? And do these all in a safe, sustainable, and environmentally just way. And this is just kind of a snapshot of really high level of the lithium-ion battery supply chain. You can see upstream, we have very limited raw material extraction. We do not have the ability to, for the most part, to produce the powders that are used in manufacturing as cathodes. That's a little bit better in anodes, but ultimately we're importing these components to make the battery cells and packs. And then of course we don't have right now the infrastructure for recycling. But it's not all bad news. We also have a lot of great opportunities. So when we look at the manufacturing sector, actually the U.S. is not leading, right? China is leading, but we are comparatively to the other folks in the game, and there's a lot of potential. So if you look at recycling, we see here this is cobalt and nickel. How much potential do we have to recover these from batteries in the United States? And you can see in about a decade, that'll peak, right, as we are able to aggregate those resources and actually recover the materials in an economic way. And you can see it takes, because they're already concentrated, right, in the cathode, or it takes much less material to aggregate than it does from ore or from brine. But at the end of the day, we need to do all of these things, because even if we have 100% recycling, demand is growing. So that's not going to be sufficient to meet the demand and meet our climate change goals. So I'm just going to highlight a couple of things that DOE is doing to support these efforts in the research, development, and demonstration arena. So in diversifying supply, our Geothermal Technologies Office has a geothermal lithium prize. This is meant, for entrepreneurs. This one is for academics trying to look at cost-effective ways to recover lithium from geothermal brines. We also have some that are further down the innovation pipeline, looking at demonstration of these technologies that are already been proven out at the labs and continuous scales to make sure the economics work so they can be commercialized. I'll talk about those just in a second. Also looking at the substitutes, right? So our Vehicle Technologies Office has been driving down the amount of cobalt in the cathodes for some time. So, the ones that are out on the market now have less cobalt than they used to. And they're continuing to work towards eliminating cobalt, since it is such there's a lot of volatility with the price, right? And it is a large cost driver. In the more, in the grid storage more broadly, right? You can use lithium-ion batteries for that, but if we can use other technologies, we can free up some materials for transportation. So looking at flow batteries, the Advanced Manufacturing Office, my home office, just competed an opportunity in this space to kind of validate these prototypes for different, like vanadium flow batteries or other flow battery systems. And then in the recycling arena, we have the Resell Center based at Argonne National Lab. It's a public-private consortium looking at direct recycling, right? So can we reuse the cathode, rejuvenate the cathode? And then we also have the battery prize, which is really looking at how to get the batteries from people at end of life to recyclers, right? And there's less focus on that in recent years. So this is really stimulating some really exciting ideas by American entrepreneurs. Some successes. So recently, Rio Tinto actually opened up a demonstration plant that produces lithium carbonate for battery manufacturing. This was developed, at least the economic processing method was developed in partnership with the Critical Materials Institute, which is an energy innovation hub funded by DOE. And so right now they're operating at 10 tons per year, and Rio Tinto is going to be scaling that up after they optimize through their demonstration to 5,000 tons per year. So this is a great start on diversifying our supply. It's leveraging waste from mining operations in California, and just adding better economics to the overall operation there. And then we also have a couple demonstration projects that are just getting started. So we have 2 projects looking at lithium hydroxide production from both clay stone and geothermal brine resources, in particular from the Salton Sea. And hydroxide is going to be more important as we continue to manufacture batteries, especially as we reduce the cobalt content. We see more use of hydroxide than carbonate in cathode manufacturing. And then we also have a project looking at production of synthetic graphite materials. The U.S. actually doesn't have any natural graphite mining operations, but we do have petroleum coke products, for instance, that you can use to make synthetic graphite. So that's what this project will be doing. So that's supporting both anode production with a graphite project, and then cathode production with a lithium project. And then just wrap it up, and I just want to put this up here. This is my home office, the advanced manufacturing office. I'm always looking to partner with folks. And there's a lot of ways to get involved. And I'll mention we do have a funding opportunity announcement on the streets right now that includes a topic on batteries. So feel free to check that out. All links will be sent to everyone. So thanks so much.
Thank you so much, Helena. So if Melanie would come up too, we'll go into some of the questions. Thank you both so much for those presentations. We already have one question in the chat, and this is from Ed Holbrook. And he wants to know, are there any projections on how the next generation of batteries, solid state, sodium, air, aluminum, hydrogen cell could reduce the extraction of rare metals? I guess either one of you, maybe.
Yeah, so I can take that. Solid state batteries, people kind of debate on when they're going to hit the market, but when they do, I think you'll see lithium metal is a contender, right? So that'll actually increase how much lithium we use, but it will reduce how much graphite we use, for instance. And then at least in those kind of batteries, we anticipate we'll still see the NMC, nickel, manganese, and cobalt cathodes. So they're not necessarily going anywhere. There's definitely continued research to reduce that cobalt content, but that also reduces the economic value of recycling. So that's tricky. And so that's something we're contending with as well. But then I think if someone I won't predict which technology is going to win out. LEDs kind of surprised us all, right? The prices went down, and all of a sudden they displaced fluorescent lighting in some applications, right? So technology always has the ability to change markets. So I think that's something you just have to pay attention to, but it's difficult to predict.
If I could say a couple things, I think that, excuse me, that we haven't mentioned in this discussion compressed air storage. And I think compressed air is where you need the least amount of metals and minerals. You need a certain geologic formation basically for compressed air, and we shouldn't leave that out of the equation. And so when I look at the question, you got aluminum, hydrogen, et cetera, there. Producing those emits carbon. And so there are life cycle emissions that we need to be thinking about too, relative to the value of what we are getting out of battery storage. So.
Great. Thank you both. So I have a question. As we add more and more renewable energy to the grid for peak demand and resiliency, either one of you, what do you see the role of lithium-ion batteries being in energy storage for renewable energy? And what are some of the challenges that you see we need to overcome?
You want to go? You can go first every time, Helena, if you want.
No, go ahead.
I mean, as I showed you in my slides, that the projections are in the world that the vast majority of lithium ion batteries will be in transportation. And and I have concerns about the duration of the storage, the 4-hour duration for lithium ion. That's why I showed the 90 days with little to no wind, because there is a limit on the duration of storage for a lithium ion battery. I showed that figure at a talk I was giving at Carnegie Mellon. I met with the battery technologist afterwards. Is there anything in batteries on the horizon to address that, 10, 11 days in a row with no wind? And they said, from a duration perspective, for lithium ion, no. Okay, and so I think that grid scale lithium ion batteries are great for ancillary services. I'm not sure for the resilience and reliability of the electric grid, which is the Uber infrastructure now. It supports every other lifeline network we have, electricity does, that we've got to be pretty thoughtful and careful about that. So that's it's your turn, Helena. So.
I don't have much to add. I'll just say that the DOE, the Energy Storage Grand Challenge, has this effort called the Long Duration Earthshot, and the idea is to develop technologies that have duration for 10 hours or more of storage. So check that out if you're interested, but definitely not my average. I don't know that much about grid storage.
Okay, and I'll go ahead, Dylan. Did you have a question?
Yeah, I had a question. We talked about this a bit on the prep call, but I wanted to raise it here. We talked about kind of the workforce and sector needs kind of evolving over time. So right now it's more in the production phase, but I think we saw the chart showing recycling needs will probably peak about 10 years from now. And then there's just kind of different workforce needs and vulnerable communities that could be supported by these initiatives, like a lot of rural manufacturing or using the vehicle electrification to support urban air emissions and help low-income populations there. So I just wanted to open the floor a bit and give some opportunity to talk about how there might be some chance to support vulnerable communities through these workforce needs and kind of the up and down the supply chain.
I raised the issue and in our prep calls about, and I'm in New Mexico today. I'm in Albuquerque, so it's obviously a metropolitan area, but I grew up in the mountains here and worry about rural America. And small towns in rural America, auto repair shops are a major source of commerce in very small towns in rural America. That will clearly go away if you electrify your personal vehicles and large heavy duty vehicles as well. And so wondering if there might be, at a minimum, potential for collection of batteries to recycle. I know that recycling, there are a lot of safety issues, et cetera, et cetera. We did talk about the spokes and the wheel basically for recycling. But I'm wondering if we could put a little thought into it. That's a DOE job. Put a little thought into how we might use the need and the value of recycling to help some rural areas in the country. So
I'll add, so one thing that we're looking at right now is coal communities, right? So as we're transitioning, a lot of these coal legacy sites have acid mine drainage or other ways to actually have a lot of, low concentrations. They contain lithium, they contain rare earth elements, they contain some of these critical materials. So our fossil energy and carbon management office is working to advance, the extraction of those materials economically and safely, and developing out regional models, right, to really develop those capabilities and help with that job transition. I think another a good model that I'm aware of is the Lithium Valley Commission. They're working, to catalyze lithium, manufacturing, right, in the Imperial Valley and the Salton Sea. And so that's another great initiative. And then I also I think, my contacts will be there, but one of the new things in the administration now is that we have this new requirement for all of our opportunities for folks to have a diversity, equity, inclusion plan. And this is not a check the box exercise. They have to have actual milestones and metrics associated with those. So I think there's a really big opportunity right now for folks to address underserved communities, including rural communities, in the projects when we're thinking about, like I mentioned, that we just ran an opportunity in flow batteries. That language was included. It's kind of a pilot, so that language to be included, but we're still learning, right? So we do view this as a conversation. So if you have contacts, or if I am your entry point, that's fine too. But yeah, we really want to learn from others as well, because we don't have all the answers.
Thank you both so much. Do we have any more questions? Okay. Well, I don't see any more in the chat. I thank you both so much for those great presentations. And if we don't have any more questions, we'll move forward with our next two presenters. Okay, I don't see any more questions. So at this time, I'd like to introduce, we're going to have some speakers from the battery industry. First, we're going to have Austin Devaney. He is the Vice President of Sales and Marketing at Piedmont Lithium. And immediately following him, we will have Harry Kumar, who is the Director of Government Relations with Li-Cycle. And this time, I'll turn it over to Austin. Thank you.
Hey, thanks, Star. I appreciate it. Let me begin sharing my screen. I've got a short presentation, and I'll be relatively quick. I kind of want to highlight on a couple of quick things in this presentation. Can everyone see that good before I get started?
Looks good, Austin.
Super. So Piedmont is building a lithium refining and resource business in North Carolina, just outside of Charlotte, about 35 miles. We've been at the working for this for about 5 years now. I've been in the lithium business for 12 years, almost all of that in the batteries. So it's great to talk to the National Association of State Energy Offices and kind of what y'all are trying to understand and learn about how things move forward to support primarily transportation and mobility applications for lithium-ion batteries. But there are plenty of other places where lithium-ion comes into play. And the United States has some great resources that we look forward to working through as an industry to help improve our climate, improve efficiencies across the mobility chain, and really provide that way will improve life for everyone. So let me jump through a couple of these slides, and I'm gonna really focus in on 3 of those. Oh, just so you want to know, that's your big, long, fine, small words for you to read. Piedmont trades on the New York Stock Exchange. We're based in Gaston County, North Carolina, just west of Charlotte. I'm not going to spend any time on this, so I'm going to move forward. We've done a couple of things this year. You can see that. This presentation will be shared through the NASEO office, so you'll be able to download it at a later date. I'm going to jump forward to this. This is, Melanie showed you a couple slides, and I kind of wanted to focus in really on this center one, but it's the left one that's driving it. It's mobility. And there doesn't matter which agency you want to use or which consultant, but really it is the penetration rates which are driving demand for these minerals. Here you can see that Bloomberg New Energy Finance is projecting that 2030 will have over a 50% penetration rate. I'll personally tell you, I'm not sure that that can be achieved with the minerals that are available in the world today. Harry may tell you that recycling will come into play and help bridge that gap during the ensuing years, but definitely one of the challenges is the amount of minerals available. But when you see the investments that car makers are making, whether it's General Motors, Ford, Stellantis, Daimler, over $100 billion being invested in that area to electrify their fleets. China has been ahead of us in that space for a number of years. And really, that's one of the things that I think is important for the United States to implement are consistent policies and policies on emissions, policies on production that will really drive the adoption of electric vehicles. What Melanie was pointing out was this center graph, and that's the fact there's a shortfall of supply. The bars, the dark blue bars are the supply, the light blue demand that's there. So you can see the difference there that is created because of that penetration rate on the left. So that's a real challenge that we face. So I wanted to highlight this page as one. I'll jump to a couple more, and then I'm going to get into a little bit of things about personally where Piedmont is. This talks about preferred feedstocks, taking share, our projects. One of the things that, if you recall, in the Biden administration was partnering with other resources around the world. So Piedmont, not only do we have our project in North Carolina, we're also developing a project in Quebec with a partner, Sayona, and then have made an investment in Iron Ridge in Ghana, a very nice jurisdiction in Africa that's very stable, has a democratically controlled government that would be a source for minerals that we could bring to the United States and process. So let me tell you a little bit about Carolina lithium. So nearly all of the Western world's lithium was produced there along that green belt from the early 1950s up until the 1990s when the last mine shut down. So you can see the two mines, they're represented by the little X's there, which are a pick and hammer. But the blue is kind of, we're a little bit further north from there. Just as a quick funny aside or interesting aside, those two sites there were developed and exploited originally to support the Manhattan Project back in the 1940s and 1950s, because lithium is used as a trigger for atomic bombs. And so that was the kind of the real inception for lithium production here in the United States in the 1950s. And we are going back to that same general area where there's a geological prominence of lithium just north of there, plan to mine product there, process product there, and produce and sell. If you're familiar with the automotive industry, there's a huge automotive swath that runs kind of in the eastern United States from Alabama all the way up into Ohio, touching North Carolina, Tennessee, Kentucky, that will be likely spots for battery plants. But this spot for lithium is a really good one, and we're excited about it. The last slide I'll tell you is one that really is super important to me, and that's sustainability, the environmental impact, and really the two on the left are the critical ones, carbon intensity, because if you're going to electrify your transportation fleet, the purpose for doing that is to reduce the carbon intensity. So Piedmont has taken it upon ourselves to make sure that we're doing everything possible by including solar production as part of our site, so that we will be renewable energy as our sources of energy, and reducing transportation of interim products, going from, as an example today, there's product that goes from Australia to China to Japan to the United States. We'll do all of that here in the southeastern United States. And then the second piece is how do you use water? Water is really one of the next frontiers of competition between resources for producing food, health, and other things. So we've made it a critical part of our strategy to make sure we reduce water footprint. So those are really the three things I wanted to highlight about what Piedmont's doing. But I think if when we get into the Q&A, I'm going to try to reinforce that consistent policies and investments in the middle part of the supply chain, because today what we've seen is investments have occurred at the R&D phase. The Department of Energy has done a fabulous job through DARPA, ARPA, and other agencies to make sure that we're finding ways to produce products in a better, faster, quicker, cheaper way than what we've ever done it before. There's also been investments at the other end of the supply chain in the customer facing applications. The middle in refining, cathode production, anode production is where the United States needs to make those investments today. So Star, that's the end of mine. I'm going to jump through these. Again, I'll make all these slides available.
Thank you, Austin. At this time, I'll turn it over to Harry, and then we'll take questions for Austin and Harry at the conclusion of Harry's presentation. Thank you.
Hi, everyone. Thank you, Star, and to the rest of the team for having me on today. I'll start sharing my screen and get this going. There we go. Let me know if you can see that.
Not yet.
Not yet. All right.
There we go.
Is that good?
Yeah, good.
Yeah.
Thank you.
Great. Yeah. Hey, everyone. I'm Harry Kumar. I'm with Li-Cycle. We were founded in 2016 by our co-founders, Tim Johnston and Ajay Kochar. They were two engineers who, chemical engineers who, saw this kind of hole in the supply chain at the end of life. And, a lot of batteries were, and still are in some cases, just ending up in landfills. And so they saw obviously an important opportunity there to help shore up a part of the supply chain and do so in a very, environmentally responsible and conscious way. And so this gives you a little background of just who we are and our vision and our mission right there. So some of the key milestones that we've reached. So in 2016, like I said, we were founded in 2016. In 2020, so last year was our first spoke was commissioned, and it has the ability to process 5,000 tons of lithium-ion batteries per year. And as you can see, we have a few other milestones that we've reached. Our second spoke opened last year in December in Rochester, New York, at the old Kodak Eastman Park, now known as Eastman Park in Rochester. And then earlier this year, we announced a facility we're opening just outside of Phoenix, Arizona, in a town called Gilbert. And so that's spoke number 3. And we'll actually be announcing a spoke 4 in the very near future. So a lot of what we've seen is in talking to different states in different parts of the country, there's definitely been a lot of eagerness and engagement to have battery recycling be a part of their supply chain, and part of their marketplace. And so then you see going forward, we're a spoke and hub model, which I'll detail a little more in the next few slides. But our commercial hub 1 will be in Rochester, New York, and so that's where we're currently going through the permitting process for that. We will have I'll have a timeline for you later to show you what that looks like, but we're hoping to break ground later this year. So here's a little bit about us. So we're committed to providing end products and lithium-ion battery resource recovery. And environmental impact is one of the big things to us. So we have zero wastewater, no direct emissions, and no landfill. And this is just a part of our overall socially responsible recycling practices that we take very seriously, and we want to make sure our customers and others understand that we're here to do this in the right way. And so we're always looking to improve our processes and get better. So this next slide details the spoke and hub model. So as I mentioned, we have those 2 spokes online right now in Kingston, Ontario, and Rochester, and then we've announced the 3rd spoke in Gilbert, and so that guy gives you a little detail about where we are. So in the spoke process, it's a shredding process and mechanical separation. And so we can take batteries of any size, shape, composition, lithium-ion batteries of any of those things, and we shred them. And so we have these different products that come out of that. So we have shredded copper and aluminum and mixed plastics. And we have offtake vendors for both of those products. But the important thing to definitely note here is the black mass. And so currently we have interim sales to nickel recovery. But going forward, once we have the hub online, obviously the goal is to be vertically integrated and have our network of spokes fill into our hub. And you'll see at the end of the supply chain on the right, that's where we'll get these high grade refined materials like lithium carbonate, cobalt sulfate, nickel sulfate, manganese carbonate. So this just details a little bit about where we are in the supply chain and what we see our role being. And I think as some of our speakers have mentioned, recycling certainly cannot replace traditional mining in full, but we certainly see ourselves as an important part of what we like to call urban mining and helping provide a stable source to help offset the need for foreign mining as much as we've had to in the past, and also work with our supply chain partners to meet this overwhelming demand, because as it's been detailed, there's certainly a tsunami of these end-of-life batteries coming over the next decade in particular from EVs. And so we're trying to make sure at this point that we're scaling up to meet that challenge. So this gives you a little detail about the spoke and hub, and I spoke to some of this, so I won't fully re-engage on this, but we have the ability to accept all sorts of lithium-ion batteries, regardless of chemistry, form factor, prior application. As I mentioned, the environmental benefits, no wastewater production, low air emissions. And then at our hub, we use a hydrometallurgical process, which is known as a wet chemistry process. So it's a low temperature operation, as opposed to the pyro process, which obviously has a higher grade temperature, and also you lose some of the mineral recovery rates in that process. So that just gives you a little background there on that. This slide just kind of tells you a little bit about our business model currently. We get requests and we provide quotes based on the battery type, and we tailor everything uniquely to each of our customers. So there's no one size fits all method. We definitely try to do the best we can to make sure that the customer's need is matched by us. So that's an important thing to life cycle. And this just details the spoke process. So this is a patented system. Like I mentioned, all chemistries, we have a neutralizing solution in the shredder. And then we have these screens where it screens out the shredded plastics and copper and aluminum foils into separate outtake trays, where we have offtake partners for those. And then it filters the black mass, which is our interim sales to nickel recovery, and easily transportable relative to batteries, which is important to note because the black mass, once it's gone through that shredding process, it is much safer to transport than traditional batteries in their solid state. So this details the hub, which is our patented process, 12 formalized trade secrets. You can kind of see the screen there and some of the output products that we'll have once the hub is up and running. And this is our hub update and key milestones. So 2020, we started the engineering, permitting, and infrastructure management work process. 2021, we've been doing a lot of work with the states and local governments in New York and in the Rochester area to make sure we're fulfilling all permitting requirements and all of that. And so we're targeting to break ground by the end of this year. And then next year obviously would be where our construction ramps up and hopefully completed by the plan is to be completed by next year and start actually have the hub online early 2023. And here we have our life cycle analysis results. This was done by an independent third party. Just goes into some of the environmental benefits of life cycle and our emission offsets factor and our water usage offset factor. As you can see, there's a pretty substantial difference from other forms and other recyclers. So in here details the pyro process versus our process, which is that wet chemistry hydrometallurgical process. So we have significantly reduced GHG emissions in comparison to competing pyro recycling processes. And we also, in terms of PFAS, that's obviously something that's always been a hot topic for a few years now. Our process does not produce that. We avoid that issue due to the hydro process that we use and that patented broken hub model with the shredding process. So this just highlights some of those benefits. And then lastly, just looking at key industry trends, like I mentioned, there's continued market growth. It's an enormous market that's only going to keep growing. There's obviously an incoming tsunami of end-of-life batteries. And, we definitely see recycling as playing a critical role in helping address that demand. And then on the right, you'll just see some of our advantages in terms of our processes and kind of what we're doing. And I think it's important to note too that we are commercial today. As I mentioned, we have the spokes online, and we actually just went public last month on the New York Stock Exchange. So that was a big milestone for us, but also just another important marker. And there's only growing work on our end following that, but we're excited about the challenge. So I'll pause there and turn it back over.
Thank you, Harry. That was great. I don't see any questions in the chat, so I'll start out with a question for Austin. During your presentation, you were talking about consistent policies will help with more widespread EV adoption, and then you mentioned a little bit more about investment at the middle supply chain. Can you expand a little bit more on that? And also, do you see any other areas where we could improve on EV adoption?
Yeah, so the first one, if you look at what Europe has done and what China's done in establishing CO2 emission limits for vehicles, the United States does it a little bit differently. They do CAFE standards and it's fuel economy, but fundamentally it works out the same way. They have established standards and have never backed away from them, and they've continued to tighten them. The United States, on the other hand, depending on the political winds, have changed them back and forth multiple times and used different methods. But the argument for an investment in a project really needs consistency. To be able to look at projects that have lives spans over 20 or 30 years, we really have to understand what is the return for that. And that's really the kind of incentive that's needed to be there, is that consistent policy. Then from an incentive standpoint, it's the same type of thing. Incentives have wavered with the winds, and depending on where we're at today, and I mean, we started the year, I think, with some of the policies that were being proposed. There were significant consumer incentives being discussed. There have been incentives that have moved away, but really, when you look at what our competitors in China and Europe have done, they've put together consistent policies. Norway is a fabulous example of a country that has moved to 75% penetration rates on EVs, and they've done that by setting a policy over 10 years ago and sticking with it throughout that term. So that's the kind of thing that needs to take place on the consumer end and on the policy end to make sure investments are happening. Now, the second piece of that, some of the things that the United States does really well, the Department of Energy has their ATVM program, Advanced Technology and Vehicle Manufacturing, has provided loans and support for many projects. Piedmont is a potential recipient of that. We've applied for that last week. And we would hope to get financing that would be a portion of that. So there are things, I'm not suggesting that the United States is all bad and that we do. There are a lot of good things that we do, but really trying to get a concerted effort across the supply chain and making sure investments are done not only in science projects at the DARPA and ARPA level, but really those things that are shovel ready, kind of helping those move along, whether it's lithium, nickel, graphite, or other pieces of the supply chain, cathode, anode processing, and not the consumer facing things. So those are the things that we could have that, through the Department of Energy could put things in place that would help the United States industry in the refining middle phases of the industry.
Okay, great. Harry, did you have any comments on that?
Yeah, no, I think Austin did a really good job of covering it. I think the big thing, like he mentioned, is having that consistency no matter where the political winds may blow, and elections have sometimes kind of put a stop-start to the investments that are needed. But I think now you're really seeing a whole of government approach. And I think it's on with both parties. You can tell in just conversations I've had with different people on the Hill or in the administration. It's certainly, I think, taken a focus from everyone, and that goes down to local, state, up to the federal government. I think the most important thing is making sure that we don't just target end use products like EVs, or just making investments in one part of the supply chain. It's definitely critical that the investments are spread out across if we want to actually make an effective push, and especially in the race with competitors like China. It's gonna take everyone rowing in the same direction, and making sure that the investments and the backing stays consistent.
Okay, great. Thank you. Thank you both. I know in North Carolina, we're doing a lot with workforce development now and working with different energy industries. And we'd like to know, how can state energy officials like myself and Dylan and other state energy officials, how can we better work with private companies like yours in the future?
That's a fabulous question. Here in North Carolina, and all over the United States, you have different levels in that separation of government, from the federal to the state to the local level. That's really where consistency is needed, and having that everyone, Harry's words, rowing the boat together is helpful. But when we look at, North Carolina is a fabulous state. I'm excited that I work here. Been working here for 12 years. But when you look at, we have some of the highest renewables penetration rates across the country, only falling behind California and Texas. When you look at solar applications, and so that really is, opening up the doors for industry to locate and understand what the benefits are to locating in your state, whether it's North Carolina or any other state. Tennessee is a great state. It's got great nuclear programs that provide low carbon energy sources. So, making sure those are part of the decision making for industry leaders, and they understand that, and having your economic development offices being partners, to me, is really kind of how we bring the battery and processing all to working together so that we can be competitive with other parts of the world.
All right. Harry?
Yeah, no, I think there's workforce needs are certainly one of our biggest gating factors. And obviously, we're, as I've mentioned, we're trying to scale up to meet the demand. In terms of our company, most of our growth will be on the operations side. And so what I mean by that is actually working at the plants. And so just to give you an example on size, our spoke facilities typically have 30 to 40 full-time employees. And then our hub will have over 100 plus employees at that one facility. One of the things that we're trying to do now is look for potential partnership opportunities in places where we're located. So, for instance, in terms of Rochester, we obviously have bespoke up and running there, and that's where our hub facility will be going. We've been trying to connect with and been in contact with the Rochester Institute of Technology, for example. So they have a Institute of Sustainability there, and then we've also been in touch with the University of Rochester, and so what we're trying to do in terms of that side of things is make sure that in the communities where we're located, we have those direct ties into the, especially the university system and trade schools, all the above, to make sure that, that people know about us, know about our presence there, what we do, and that we have, we will have significant needs or for both technical and non-technical skill jobs. But I think an important part of it for us is making sure that we're making that known to universities and other schools in the communities that we're in.
Great. Those are both great answers. Do we have any other questions from anyone?
I just had a quick question, kind of expanding on the last one. I was just wondering if there's any specific workforce needs or kind of skills that you're looking for that you haven't been able to find, possibly, that states could maybe focus in on their workforce training. And also, I know that there's some fears around the safety of lithium batteries, especially for first responders and other kind of fire hazards, things like that. So I was just wondering if you could kind of touch on kind of the specific skills that if there's kind of a skills gap for the workers that you're looking for, and then also touch on some of the safety concerns.
Yeah, I'll be happy to step in and answer. So the skill gaps. I'm not, we're where our facility is going to be located in Western Gaston County, North Carolina. We're about 35 miles from Charlotte. Shelby, Hickory, Lincolnton are towns that are nearby, but we're going to have 500 plus employees there during the construction phase, and 500 plus full-time employees permanent. I'm worried about getting employees there, to be honest. It doesn't, skill level or otherwise, because we'll train employees. I mean, we're chemical operation. We'll follow all of the American Chemistry Council codes and safety standards, and train and develop employees in a manner. I'm not overly concerned about the skill sets that we'll need as much as I am actual being able to get the labor and demographics in the area, and in terms of ages, and finding people who want to come work in a career and work 20 plus years in a chemical plant. When you talk about safety in the lithium space, lithium has the highest electrochemical potential of any metal out there. It's one of the reasons it's really good for batteries, is it stores a lot of energy there. So it needs to be respected and handled safely, just as you would any other energy dense material, whether that be gasoline, propane, or some other material. The companies that I've worked for in the past in Piedmont, we will work with our local responders to make sure they understand how to manage our chemicals safely, but we're not handling lithium metal. Lithium metal is a little different beast, and it's a little more energy dense just because of its concentrated. Cathode material has energy there, and first responders today, I can tell you the Fire Prevention Society and some of the others are putting training at the top of their list for electric vehicles, and we'll support that. I'm sure Harry's Life Cycle will support that, but there's a lot of safety that's incumbent with handling any energy dense material.
Great, thank you. And Melanie, I see your hand up with you.
Yeah, Melanie has a question.
Yeah, it's not actually a question, but I just wanted to, in this whole discussion, we have not talked about domestic mining. We've talked a lot about the metals and minerals needs, and how clean energy is going to be much more metals and minerals intensive than fossil fuels. And I just wanted to point that out, and say that we need to think very, very carefully about net zero mining and the impacts of the electricity use, the water use. I know they're looking at this in Australia and in Canada, and I think that we need to think very seriously about where we can open up domestic mining, but do it in very environmentally responsible ways. And electric vehicles, we're talking about batteries here. Electric vehicles are filled with copper. Okay, so are wind turbines. Okay, a lot of and we do have. I'm in New Mexico today. We have a lot of copper in New Mexico, and so I think that maybe that's an issue for another day, but it is related to what we're talking about here. The cobalt in that's coming from Democratic Republic of Congo is being mined by 5-year-olds. There is a group of people who think that's good because they have jobs. Okay. But somebody mentioned, I don't know if it's Austin or somebody mentioned the supply chains as well, that we're shipping, things all over the planet, and the cathodes and the anodes, and we don't have X, and we don't have Y, so we have to ship out a lot of what we're doing here. Global shipping emissions are not counted in anyone's NDC. And when you're talking about net zero, that becomes a very important issue. So anyway, just a couple of thoughts on the mining needs. So.
Thank you, Melanie. Do we have any more questions for any of our presenters this afternoon? Okay, I don't see any, so I'll turn it back over to Dylan.
Great, thank you so much, Star. And thank you to the rest of our presenters for taking the time out to speak with NASEO's members about this. I think it's such an important topic, and with all the infrastructure funds coming out, really timely as well. So thanks again, everybody, for joining. I appreciate all your time. And hopefully this is more of the start of a conversation rather than the end of it. So thanks, everybody, and enjoy the rest of your day. Bye.